Okay, so we're going to be talking about position versus time graphs. So a position versus time graph is going to graph an object's position versus its time. So let's say we have a car, and our car it's starting here at, we'll call this the origin. So its position when it starts at 0 seconds is at the origin. Now that car is going to start moving forward. And so over time, after a second, it's here, and then it's moving, and it makes it to there, and it's moving, and it makes it to there, and it's moving, and it makes it to there. So over time, its position is changing as time continues on as well, as it moves forward. And by the end, it's now moved over there. Now, if we wanted to graph that, let's say this is 1 meter, 2 meters, 3 meters, 4 meters, etc. So it started out at 0 seconds, it started here at 0 meters at the origin. And after 1 second, it had made it to 1 meter. And after 2 seconds, it had made it to 2 meters, and 3 seconds, and 4 seconds. So if I'm going to graph that, then at 0 seconds, it's at 0 meters. And then after 1 second, it's made it up to about 1 meter. And after 2 seconds, it's made it up to 2 meters. And after 3 seconds, it's made it to 3 meters. And 4 seconds, it's made it to 4 meters. So here, in reality, it's moving forward along the x-axis, along a road. But on a graph, that actually looks like a diagonal line, because as time is moving forward, your position is also changing. One thing you do have to make sure when you graph something is that you use a best fit line. So you're not going to want to connect these dots. You're going to want to use a line that goes through them as best as it can. Now, the slope of this line is really important, and that's really what you're looking for on a position time graph, is the slope of the line. Now, why is slope important? Well, if you remember graphs in your math class, you learned that slope was equal to the change in y over the change in x, or y2 minus y1 over x2 minus x1. So you found 2 points that fell on the line. Don't pick 2 dots. Pick 2 points that fall on the line. And then you figure out how much the y changed, how much the x changed. It's rise over run. And that gives you the slope of your line. Now, why is that important? Well, slope is your change in y over your change in x, which in our case, our y-axis is actually the x position. So when we do the change in y, what we're looking at is the change in position over our change in x, and x is the time. So we're looking at our change in position divided by our change in time, or our change in x over our change in t, and we know that change in position over change in time is how you find velocity. So the slope on this graph is equal to the velocity of the object that you're graphing. So one other thing you can get from a position versus time graph, so we know that y is equal to mx plus b. That is the equation for a line. In this case, the y value is our x, our position. The x is time, and the m is the slope, whatever the slope happens to be. And then what's this b? Well, remember the b is the y-intercept. So, in this particular graph, the y-intercept is 0, so that would go away. But let's say that our car didn't start at the 0 position. Let's say our car started here. Well, that means that our first point on the graph at 0 time would actually be up here at 2, which means that the slope, and then if it did the same kind of 1 meter per second, it would look the same, except the slope would be the same because the speed is the same, but it started a little bit higher in position. So it's going to make it a little bit further. So in this case, here, you would have a y-intercept, right? So you'd have a number there. So this, you can write the equation for the line, and you can glean information from that equation. If you happen to have the line equation, you can figure out stuff from that. So in the first example, we didn't have a y-intercept, so x was going to be equal to m was the slope, which was the speed or velocity, times the time, plus 0, so that goes away. And so x is equal to vt. Or if you arrange that, v is equal to x over t. Okay, so now we know that the slope of a position versus time graph is the velocity of the object. And if you have a straight slope, just a non-changing line, then that indicates that you have a constant velocity. So for each second, you're changing the same position as we saw before. After 1 second, we had gone 1 meter. After 2 seconds, we'd gone 2 meters. So every second, we were increasing by 1 meter, or we have a velocity of 1 meter per second. And that would be our slope of our line, would be 1. So if you have a straight line, then that indicates that you have a constant velocity. But let's say that your car is moving, and after a second it's here, and after a second, another second it's here, and then it's here, and then it's here, and then it stops, and it's here, and it's here, and it's here. And no longer is your position changing, but time does continue to go on. And so what that ends up doing is your car is moving, 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 and then your position no longer changes, but your time continues to move. Okay, so this is a constant velocity. This is stopped. If you have a horizontal line on a position time graph, it does indicate that you've stopped. So we're moving, our position is increasing. We're moving, our position is increasing forward. And then we stop for a while, and we stop, and we stop, and then we decide to go back. Now our position, let's say this was at 5 meters and this is at 0 meters. So we were at 5 meters, and now we're at 4, 3, 2, 1, and we're moving that direction. So here we had moved forward, and then we stopped for a while, and then we start moving back. Time continues on, but we're at 4, and then 3, and then 2. Okay, so if you have a negative slope is going to indicate that you have a negative velocity. And a negative velocity means that you are going back where you came. Your position is going back. It doesn't mean that you're in reverse. You could have turned your car around, but you're moving your position back to where you came from in some way. Now, we said that if you have a straight line, a constant slope, then that indicates you have a constant velocity. But what if your slope changes? So here we had this slope, and then our slope changed to 0. And then we have a negative slope. So that means that since our slope changed, our speed changed. In physics, we call that some type of acceleration. So any place where you have a change in slope, you also have a change in speed, and so you have acceleration in those places. Now graphically, it could be that you have constant velocities like this, and then they just change all of a sudden. But in reality, you can't quite get from moving to stopped without slowing down. Then you're stopped, and then you turn around and start going the other direction. So in reality, often you see this graphically, you see these nice corners, but in reality, you have more of a curved area in which your velocity is changing. So anytime you have a curve on a position time graph, that indicates some type of acceleration or a change in velocity. So hopefully that gave you an idea of position versus time graphs and what they mean and what the slopes of the line mean on them. So I'm going to make another video which you can watch that's going to go into what the different shapes of the lines on position time graphs mean in terms of whether or not you're speeding up or slowing down or going at constant speed, positive velocity, negative velocity. So go ahead and make sure to watch that one as well.
What are you doing, Mama?
Making a video.
What?